Faster than the very fabric of space-time can adapt, Polaris is poised to tear apart, an unsettling prospect that has many astronomers on edge. Our night sky is rapidly evolving, and within just a few decades, or perhaps even years, it could become entirely unfamiliar. Scientists around the globe are sounding the alarm, and recent confirmations from experts like Neil deGrasse Tyson about Polaris's impending explosion have only intensified the concern. Polaris, the iconic North Star, has been a timeless fixture in our sky, a reliable celestial guide for navigators, astronomers, and dreamers. But this guiding light, long a symbol of constancy, may soon vanish, forever altering not only the night sky, but also the foundational measurements of astronomy. In this deep dive, we'll examine the potential threat posed by Polaris's decline and what its disappearance could mean for us all. For centuries, Polaris has held a revered place in both science and culture. Its unchanging position in the night sky helped ancient mariners navigate treacherous seas and allowed astronomers to map the heavens. Yet in September 2023, a research paper presented by the prestigious Royal Astronomical Society cast serious doubt on Polaris's future. According to their findings, Polaris is on the brink of stellar death, an event that could see it disappear from view forever. To understand the implications, we must first appreciate what makes Polaris unique. Also known as the pole star, it lies almost directly above Earth's North Pole, which is why it appears stationary in the sky. Located in the constellation Ursa Minor, the Little Dipper, Polaris is a yellow-white supergiant star far larger and brighter than our Sun. But it isn't alone. It belongs to a triple star system. Polaris A forms a close binary pair with a smaller companion, while Polaris B orbits farther out. The gravitational interplay between these stars influences their orbital behaviors and the star's pulsation patterns. Despite ongoing research, many of the details surrounding these interactions remain unclear. Situated approximately 323 light-years from Earth, the light we currently see from Polaris began its journey over 3 centuries ago. If the star were to explode today, we wouldn't witness it until more than 300 years later. In fact, it's entirely possible that Polaris has already exploded, and we are simply awaiting the light from that cataclysmic event to reach us. Historically, Polaris has been more than just a navigational tool. It has served as a powerful symbol of constancy and direction. Its dependable position and brightness made it invaluable to ancient civilizations and crucial to modern astronomy. As a Cepheid variable star, Polaris pulsates in a predictable rhythm, making a critical tool for measuring cosmic distances and calibrating astronomical instruments. But recently, Polaris has deviated from its usual pattern. Its formerly stable pulsations have become erratic, baffling astronomers and prompting concerns that it may be approaching the end of its life. The elongation of Polaris's pulsation period, now increasing by 4 to 5 seconds each year, may seem minor, but it carries significant implications. Some scientists attribute this to gravitational interactions within the triple star system, which could be altering the star's atmospheric structure and pulsation behavior. Others, however, believe these changes are signs of something far more dramatic, the beginning of a collapse that could lead to a supernova. Polaris's behavior bears striking resemblance to that of Betelgeuse, the famous red supergiant in Orion. Both stars have exhibited unexplained fluctuations in brightness, sparking fears of an imminent explosion. While NASA has openly expressed concern about Betelgeuse, Polaris has received comparatively less attention, despite showing similarly alarming signs. As massive stars near the end of their life cycles, they progress through various phases, from the main sequence of red giant stages, before culminating in a supernova explosion. Many astronomers now believe Polaris has entered the helium fusion phase, common in stars that are nearing the end. While these irregularities suggest an impending end, no conclusive evidence of a supernova has been confirmed. Yet, if Polaris were to go supernova, the event would be nothing short of spectacular. It could briefly outshine the moon, becoming one of the brightest objects in the night sky, and remaining visible for weeks or even months. Familiar constellations like Ursa Minor and the Big Dipper would appear altered, and the celestial landmark we've long depended on would vanish. Fortunately, Earth would remain safe. Given Polaris's distance and mass, a supernova wouldn't pose any direct threat to our planet. And although it may not rival the visual intensity of Betelgeuse's potential explosion, Polaris's demise would still be visible to the naked eye and captivate the global scientific community. However, it's important to clarify a key point. Despite the fears, Polaris may not explode as a supernova at all. While massive stars end their lives in dramatic explosions, Polaris may follow a quieter path. As a star not quite massive enough to undergo a true supernova, it is more likely to shed its outer layers and transition into a white dwarf. This process, though less dramatic, would still mark a profound change, leaving behind a dense stellar remnant about the size of Earth, but no longer visible to the unaided eye. Even so, studying Polaris's current behavior and comparing it to historical supernova events like SN 1054, which created the Crab Nebula, or SN 1987A in the Large Magellanic Cloud, can provide valuable insight into stellar evolution. These past events have helped astronomers understand the formation of nebulae, the release of cosmic rays, and changes in luminosity, phenomena that may offer clues about what to expect from Polaris. The Crab Nebula, for instance, continues to expand and radiate energy, serving as a treasure trove for astronomers. Similarly, SN 1987A offered critical insights into nucleosynthesis, the creation of new elements during a star's explosion, and the dynamics of supernova remnants. If Polaris would undergo a similar transformation, we could witness the formation of a nebula, the enrichment of interstellar matter, and the creation of new building blocks for stars and planets. In short, Polaris is more than just a star. It's a cosmic touchstone, a navigational anchor, and a scientific mystery. Whether it ends its life in a brilliant burst or fades away quietly into a white dwarf, its story marks a turning point in our understanding of the cosmos. The sky above us is not fixed. It's evolving, and Polaris's transformation may serve as a luminous reminder of the universe's dynamic, ever-changing nature. Material accelerated by the shock wave of a supernova significantly impacts astrophysical processes and contributes to cosmic radiation environments. To make accurate comparisons, scientists examine differences in the mass composition and velocity of ejected material between Polaris's anticipated explosion and previously observed supernova events. This involves analyzing light curves, spectra, and remnants from past explosions, then projecting similar characteristics for Polaris's expected outburst. Understanding whether Polaris's detonation could produce a nebula or distinct elemental patterns helps refine predictions about its potential consequences. Another key area of investigation is the pulsational variability observed in dying stars, like Polaris, and comparing this behavior with known supernovae or their precursors. Such comparative studies help identify patterns or anomalies that may offer insight into mechanisms triggering stellar eruptions. Pulsational irregularities in stars nearing the end of their lifespans often point to internal instabilities or looming catastrophic events. These fluctuations serve as clues to the underlying evolutionary processes leading to supernovae. Despite thorough monitoring and analysis, Polaris continues to baffle astronomers with its erratic behavior. Decoding the unique conditions behind these anomalies is essential for deepening our grasp of stellar evolution. Gaining a clear understanding of the forces driving Polaris's irregular pulsations requires interdisciplinary collaboration, advanced theoretical modeling, and innovative observational techniques. The potential loss of Polaris, a vital celestial reference point, raises serious concerns in astronomy. Ground-based telescopes and astronomical measurement systems will require recalibration, potentially reducing precision of observational data. Additionally, Polaris's disappearance could disrupt navigation systems and cultural traditions that rely on its presence in the night sky, highlighting the broader implications of this cosmic event. Polaris's enigmatic behavior underscores the urgent need for more focused research and in-depth exploration. Astronomers must untangle its complex pulsations and offer definitive explanations, recognizing that expanding our understanding of such celestial phenomena is critical. While Polaris's fate remains uncertain, the ongoing effort to comprehend it reflects humanity's enduring pursuit of knowledge amid cosmic unpredictability. The possible demise of Polaris also raises thought-provoking questions about the future of other stars. Its transformation, along with that of Betelgeuse, reminds astronomers of the dynamic and ever-changing nature of the universe. Many stars are currently in similar evolutionary stages, exhibiting unstable behaviors. such as fluctuating brightness or irregular pulsations, which may signal that they are approaching the end of their life cycles. Such variability often indicates a star is burning through its final reserves of fuel. These stars become natural laboratories for studying the processes behind stellar collapse and supernova formation. Beyond isolated stars, researchers also examine star clusters, where groups of stars evolve under shared environmental conditions. Studying these systems provides valuable insight into how gravitational interactions and common material influence stellar development. Within these clusters, phenomena like mass transfer between stars can significantly alter evolutionary outcomes. Finally, examining supernovae and the remnants they leave behind offers profound knowledge about the universe. The violent death of massive stars reveals vital data about matter distribution, energy release, and the ongoing cycle of creation and destruction in the cosmos. Supernovae eject immense quantities of material into space, enriching the interstellar medium with heavy elements. These materials play a vital role in the formation of new stars and planets, underscoring the profound interconnectedness of the universe. The remnants of these stellar explosions often form nebulae, vast, colorful clouds that act as stellar nurseries where new stars are born. By observing these processes, astronomers can unravel the cosmic cycle of birth, death, and rebirth among celestial bodies. The effects of supernovae reach far beyond their immediate surroundings. These explosions can influence the rate of star formation in nearby regions, ultimately shaping the development of entire galaxies. The shock waves they generate compress surrounding gas clouds, triggering the formation of new stars. In this way, the life and death of a single star can set off a ripple effect across the cosmos, impacting galactic evolution over billions of years. With advancing technology, astronomers are better equipped than ever to study these phenomena. Space-based telescopes and ground observatories employ cutting-edge instruments to capture detailed images and spectra of distant stars. This data helps scientists build models of stellar evolution and make predictions about stars like Polaris. Artificial intelligence and machine learning are also transforming the field, enabling researchers to analyze massive datasets more efficiently and uncover hidden patterns. Beyond their scientific importance, astronomical events have had a deep cultural impact throughout human history. Celestial phenomena have influenced myths, navigation, and collective human imagination. The North Star, for example, has served as a symbol of guidance and hope across civilizations. As our understanding of the cosmos grows, so does our appreciation for the ways in which these awe-inspiring events shape both the universe and our shared human experience. Let me know if you like this show